There are several types of air navigation systems in use today, each serving specialized purposes. Navigation systems include any method a pilot uses to follow a predetermined flight path over the Earth's surface.
A navigation system may be totally aircraft-based, such as an inertial navigation system, which does not require outside visual, radio, or radar contact. Or it can be entirely ground-based, with ground radar continuously monitoring the position of the aircraft and navigational guidance given to the pilot over the radio.
The most common system uses a combination of ground and airborne equipment. Ground equipment transmits signals to airborne receivers, and pilots then determine and control ground track on the basis of instrument indications. The Very High Frequency Omnidirectional Range, abbreviated VOR, and sometimes called OMNI, is the primary navigation system for civil aviation.
Military and naval aviation uses a comparable system which transmits data on ultra-high frequency called Tactical Air Navigation, or TACAN. Most VOR sites also have an operating TACAN. The combination of the stations is called a VORTAC. A VORTAC has two distinctly different transmitters and antenna systems at the same site. For now, our discussion will deal only with the VOR, and we'll refer to both VORs and VORTACs as VORs. The VOR station is easily spotted from the air. It is a small, low building topped with a flat white disc which houses an antenna system. This is the sectional chart symbol for a VOR. Here is the symbol for a VORTAC. The frequency for the VOR is shown in a box near the station symbol. Sectional charts do not show TACANs. A compass rose is centered on the VOR symbol. The compass rose and the VOR are aligned with magnetic north. Everything else on the sectional chart is oriented with true north. In sections of the country where there is considerable magnetic variation, the compass rose appears to be tilted. Pilots can select 360 different courses when navigating with reference to a VOR. Courses emanating from a VOR are called radials. Radials are defined as magnetic courses from a VOR. This is the 360-degree radial extending north from the VOR, and this is the 180-degree radial extending south from the station. To keep your semantics straight, radials are the spokes which radiate from a VOR, and bearings are the courses flown either to or from a VOR. For that matter, bearings and courses are the direction flown to or from any point on the surface. The Airport Facility Directory will show unusable radials of a VORTAC, such as the Helena VORTAC in Montana. The 035-degree through the 050-degree radials are unusable below 12,000 feet beyond 25 nautical miles, among others. VOR signal reception is line of sight and varies according to the altitude of your airplane. Obstructions, or the curvature of the Earth in the direct line between the airplane and transmitting station, will block out VHF signal reception. At 1,000 feet above the altitude of the transmitting station, normal reception extends to 40 nautical miles from the station. The reception range is proportionately less at lower altitudes. VORs are identified by a 3-letter Morse code shown on charts. If a VOR is transmitting while undergoing maintenance, the station will either transmit the Morse letters TEST or remove the identifier altogether. This is done to inform you that the VOR signal may be inaccurate or unreliable, and the station should not be used.
Listening to the signal to identify the station is extremely important. First, be sure the correct station is tuned in. And second, be certain the station is operating normally. The accuracy of the VOR system depends on proper adjustment of both the transmitter and the receiving equipment. With the transmitter and receiver operating normally, accuracy is generally plus or minus 1 degree.
The VOR receiver has a volume control, ident switch, and frequency selector. Frequencies for VORs range from 108 to 117.95 MHz. Pulling the ident switch allows you to hear the Morse code identification along with any voice transmissions over the VOR. With the switch pushed in, the Morse tones are suppressed, making it easier to hear voice transmissions. The VOR indicator has an omni-bearing selector, abbreviated OBS, a course deviation indicator, a CDI for short, and a to/from indicator. There are a couple of ways to show that no signal is being received or that the signal is too weak. Some indicators show an off flag. Others just do not show a to or from indication. As the name implies, the omni-bearing selector is used to select the bearing, or course. When a course is selected, the course deviation indicator shows the position of the selected course.
The indications of the CDI and the to/from indicator are not affected by the heading of the airplane. At any location, if the CDI indicates the selected course is to the left, the CDI will always be to the left, no matter which way the airplane is pointed.
Because you will see the same indication on all headings, the left and right information is only valid when the airplane is pointed in the same direction as the selected course. The left and right CDI indications will be correct if the airplane heading generally agrees with the course selected on the OBS. Think of the airplane as the center dot and the needle as the selected course. If the needle is centered, the airplane is on the selected course. If the CDI is pointed to the right, the selected course is to the right of the airplane. A needle to the left means the course is to the left. A full-scale deflection of the CDI represents 10 degrees. Because this information is angular, the actual distance off course depends on the distance from the station. A half-scale, or 5-degree deviation 10 miles from the station puts you about a mile off course. 30 miles from the station, the same deviation puts you about 3 miles off course. The to/from indicator shows whether the selected course will take the airplane to or from the station. Some manuals call the to/from indicator the ambiguity meter, so named because it resolves the ambiguity of whether the selected course will take the airplane to or from the station. From the north on the 360-degree radial, a bearing of 180 degrees to will take the airplane on a course to the station. The same course from the south will take the airplane from the station. The to/from indicator measures the radials that are at right angles to the course set on the OBS. When crossing those radials, the to/from indicator will flip even if the airplane is miles away from the station. Remember, VOR indications are not changed by the heading of the airplane. In all three airplanes, with the OBS set to 180 degrees, the CDI is centered with a from indication. Turn the OBS to 360 degrees, and the CDI will again be centered with a to indication. The heading of the airplane only affects how long the CDI will remain centered. If the airplanes continue on these headings, the CDI will not stay centered.
Orientation is a word you'll hear a lot. The dictionary defines it as determining one's position. If you have to determine your position, you probably aren't lost, but merely not sure of your exact position.
As an example, flying from the Clark Airport to the Mineral Wells Airport using the VOR to locate yourself is fairly easy if you follow some simple steps. First, tune the VOR receiver to a nearby VOR. Remember, you aren't really lost. You know that you are in a certain area. After you have identified the station, turn the OBS to center the CDI. Don't rush this. Spinning the OBS too fast will make the CDI move like a windshield wiper. When the CDI is centered, you have all the information you need. Read the course from the OBS and to or from on the to from indicator. If the OBS is on 194 degrees with a from indication, you can draw a line from the MILSAP VOR on the 194 degree radial and know that you are located somewhere on that line. To fix your position on this line, you could look for a landmark or find your position in relation to another VOR. The Glen Rose VOR is close to your line of position. Tune to the Glen Rose VOR. Repeat the process, and the CDI centers on the 310 degree radial from the Glen Rose VOR. Your position is where the 310 degree radial from Glen Rose intersects the 194 degree radial from MILSAP. To find a bearing to the MILSAP VOR, tune in the VOR. Set the OBS to center the CDI with a to indication. The OBS is on 014 degrees, so turn the airplane to a heading of 014 degrees. As you fly inbound, make heading changes to keep the CDI centered. As you get closer to the station, the heading corrections needed will be smaller. This is because radials are like the spokes of a wheel. They converge at the station. Within a few miles of the station, you will notice the CDI and the to from indicator flickering. The size of this cone of confusion is relatively small at low altitudes and increases with altitude. Do not mistake this cone of confusion for station passage. Station passage is indicated when the to from indicator makes the first complete reversal to a from indication. The Mineral Wells Airport is on the 307 degree radial and 4.6 nautical miles from the MILSAP VOR. After crossing the VOR, change the OBS to 307 degrees and turn the airplane to 307 degrees. Then, make small corrections as needed to keep the CDI centered. Use small corrections because the airplane is very close to the VOR. 4 nautical miles from the station, a half-scale deflection of the CDI amounts to less than a half mile off course. You might encounter some minor course roughness on VORs. Some receivers are more susceptible to this than others. Course roughness can be caused by rough terrain and appears as CDI or to from indicator fluctuations.
Like the VOR, TACAN provides line-of-sight information transmitted on ultra-high frequencies. Receiving equipment for the TACAN course, also called the azimuth feature, is generally not available for civilian aircraft. TACAN has another feature, which is a distance measuring capability. Equipment to use this feature is available and installed in many civilian aircraft.
Distance Measuring Equipment, DME, does away with the need for a crossfix from another VOR to establish the aircraft's position. The pilot selects the frequency of the VORTAC on the DME. The airborne DME sends a signal which triggers a response from the ground station. The airborne equipment measures the time the round-trip signal took and presents the information as nautical miles. Some DMEs also show ground speed and time to the station. Some VORs only have the DME feature of the TACAN. These are called VOR DMEs and are shown on charts by the VOR hexagon symbol inside a square. Although VOR DMEs aren't equipped for TACAN use by the military, civilian pilots can get distance from the station if their airplane is equipped with distance measuring equipment.
A VOR receiver used under instrument flight rules must have been operationally checked for accuracy within the past 30 days. While this check is not required for VFR, it is certainly a good operating practice. There are several ways to check the accuracy of a VOR receiver.
The Airport Facility Directory lists designated ground and airborne receiver checkpoints. At these locations, a specified radial should be received. Allowable error for VFR is not prescribed. For IFR, the ground check error cannot exceed 4 degrees. Maximum error using the designated airborne check is 6 degrees. Another way to check the VOR is the Very High Frequency Omni Test, or VOT. VOTs provide a convenient means of determining the accuracy of a VOR receiver while the airplane is on the airport where a VOT is located. Use of VOTs while airborne is strictly limited to those areas and altitudes specified in the Airport Facility Directory. VOTs are identified by either a continuous tone or a series of dots. VOTs transmit the 360-degree radial in all directions. No matter where the aircraft is located, the VOR receiver will indicate the 360-degree radial. Electronically, the aircraft is always located north of the VOT. There is no prescribed accuracy requirement for VFR use. For IFR, the CDI must center within 4 degrees of 360 degrees from, or 180 degrees to.
It's recommended that VOR receivers be recalibrated annually. Radio repair shops have a test signal generator, similar to the VOT, which is used to calibrate VOR receivers. As Dick Collins said earlier, don't think of yourself as lost, just temporarily misplaced. With the help of nearby VORs, you can easily pinpoint your position.
Most of the references to navigation in private pilot training are to VORs and NDBs and compasses and clocks and charts. The charts will be around, but there's a new form of navigation coming that will replace the VOR and the NDB in the not-too-distant future. GPS stands for Global Positioning System. It uses a constellation of 24 satellites to provide very accurate navigation anywhere in the world. While there's currently no emphasis on GPS in the FAA tests, there may well be a GPS navigator in the training airplane that you fly, or you may have bought yourself one of those great portable GPS navigators available through Sporty's catalog. We're not going to teach you how to use GPS here, but we think it important that you know some of the advantages of GPS. GPS units have a database, and most of these include every radio navigational point that is charted by the FAA, plus all the public use airports. Every VOR, NDB, and intersection is there. With GPS, you can get information on navigating direct to any point in the database, or you can put in a flight plan that will guide you from one point to another, and on to your destination. GPS gives information on your position in relation to a desired course, like a VOR, and gives distance and ground speed, like a DME, and GPS is more accurate than either. GPS units, whether portable or installed in the panel, offer a lot of other information too. They may have all the frequencies for an airport, airport diagrams, maps of the terrain, and regulated airspace, plus the time of sunset and sunrise for airports, and many have a vertical navigation feature that helps in descent planning and management. GPS will tell you the track being made good over the ground. Track is an especially important GPS feature because when flying cross-country, track is what gets you where you're going. GPS takes all guesswork out of correcting for wind drift. If you keep the track matched to the bearing to the next point, you'll go there. Newer GPS units update track so quickly that in shallow bank turns, the track information is as good as that you get from the heading indicator, and it's much better in turns than information from the magnetic compass. Most GPS navigators will tell you how long you've been flying and give you an ETA for the destination. If you want to know about the nearest airports, that information is but a button press or two away. Despite the training emphasis on VORs and NDBs, there are a lot of pilots around, and I'm one of them, who've used GPS as a primary form of navigation for years. GPS is wonderful. It's more precise, it makes navigating easier, and it puts a world of information at your fingertips. LORAN, incidentally, is a different system based on ground stations, and while it has little formal role in the system, it does what GPS does. It'll be around for a while, and you may fly an airplane with a LORAN navigator installed. There are different brands of GPS navigators, and there's really no standardization on how to operate them. That's good because it leaves each manufacturer to try to do better than the others and to pack more features into their navigators. Good old competition, in other words. Most GPS navigators can be learned in a relatively short period of time using the instructions manuals. Sporties has DVDs on using GPS for en route navigation as well as on flying instrument approaches. GPS is there to use now, and while it may not be emphasized in private pilot training, once you get your private certificate and start exploring the sky on your own, you'll find GPS a wonderful way to meet the challenge of navigation.